Hello, everybody. I am Joanne Daryl Avillera, a faculty of the Natural Sciences Department at Lyceum Northwestern University. So I will be your statistical biology instructor. To begin with, let's define statistics. So statistics is the field of science of learning from the data. So statistics is the collection, identification, and of course, analyzing the data. So your subject is statistical biology. So we're going to mix that statistics from biology. And what is the role of statistics in biology? So statistics helps biologists to correctly prepare experiments and verify conclusions and properly interpret the results. So, in short, biostatistics is the application of statistical principles to question and problems in medicine, public health, or in biology. So, the discipline of biological statistics provides tools and techniques for collecting data and then summarizing, analyzing, and interpreting it. So if the sample one takes a representative from the population of interest, they will provide good estimates regarding the population overall. So consequently, in biological statistics, one analyzes samples in order to make inferences about the population. And there are two main categories of statistics, namely descriptive and inferential. Descriptive statistics describes the data. It is also has a simple interpretation, and the final results are shown in graphs or even in charts. And the statistical measures that we're going to use in descriptive statistics are usually the central tendency, the skewness, and of course the spread. And and from inferential statistics, we have to take the data from the sample and make inferences about the larger population. So this one is a complex process, and we have to make conclusions about the population that is beyond the data available. And the statistical measures that we're going to use here are hypothesis testing, confidence intervals, and regression analysis. So soon, we're going to discuss more further about the statistical measures because in the future, you're going to use that one in your thesis. And of course, it will help you a lot in solving your statement of the problem. Now, let's define some terminologies. Okay, so we have the data and variable. So what do you mean by data and what do you mean by variable, and how does these two differentiate? So is your first one is your data. So the data has individual observations, and it is the observations are made on the variables, while variables is an attribute that describes a person, thing, or an idea, and something that can be controlled. So this, so we have a table here, okay, in which, so in our table here, the upper portion, so the gender, age, the height, the weight, and of course the patient numbers are your variables. Okay, while this inputs that is located here or inside your table these inputs here are your data. Okay, so I'm hoping that you can see the differences between the data and the variable. So the data are the individual observations in which patient one, he um, is a male, age 59 with a weight of 175. So those are their observations. While the variables are, these are the attributes that describes what are you looking for. Okay? And something that can be controlled. So you can control um, what do you want to know on your um, what do you want to know in your study. Okay. Then we have another words here, which is sample and population. Now, how does these two differ? Population is an aggregate of creature, things, or cases, and it is also the elements from a set of data and the entire group that you want to draw a conclusion. So that is a population. While sample contains most of the information about the particular population, and then it is also specific that you want to collect your data. So here is an example so that you can understand better. So this large portion here is your A. So this is your population, a large portion of the group of people. You want to know this. You want to know about this certain group of people, and then you're going to select only who you want to be part of your study. So that is your sample, who you want to be part of your study. And then you're going to do, of course, um, your statistical measure here. Then you're going to draw your inferences based on the population that you gather. Okay. So another example is that, for example, uh, we have Philippines here. Okay. So Philippines, the whole Philippines is your population. Okay. Then you want to um, that is your general population, the entire population of the Philippines. Okay. And then to be more specific, you're going to gather only the certain individuals or ethnic groups. So you want to study only in Pangasinan, where the Gupan is located. So Pangasinan. So you're going to include all people in Pangasinan, and then you want to pick only those individuals who you want to conduct your study, and that will be your sample. Okay. So the population and the entire population is a certain group of people or cases that you want to study, and then you just going to pick only the individuals or the cases that you want to include on your study, and that is your sample. So another example that we have here is the candy store. Okay, so in the candy store you want to include only on portion this portion of the candy store. So that is these are the candies. And in those box or in those container, you only want to determine which of those candies that you want to to draw your sample. And pick Reese's chocolate, or you want to pick Hershey's. So Reese's and Hershey's will be your sample. because you only want them to be part of your study. Okay. Now, in statistics, we have probability sampling methods because let's go back to your population. Because in your population, okay, how are you going to determine who among these individuals will be part of your study? Okay. So we have probability sampling methods. So the first one is simple random sampling, in which each member of the population has the equal chance of being selected. And then systematic sampling, wherein individuals are selected at regular intervals from sampling frame, followed by stratified sampling, wherein it is used when there are subgroups within the population, and clustered sampling or subgroups of the population are used as a sampling unit rather than individuals. Now, this is an example, okay, to further understand what do you mean by those. Okay. In simple random sampling, okay, if this is your okay, so if this is your whole population, so everybody has the chance to be part of your study. So it is just like winning a uh what do you call that one? Just like in a lottery. Okay, so everybody has a chance to win, but of course you needed to draw the numbers. Who among of those people will be part of your study? Okay, and then um how are you going to do that one is, for example, you have 100, your population is 100, then you only want uh, um, 10 individuals to be your sample, to be your sample, your sample size. Then you're going to number them, 1 2, you're going to assign number on each individual, 6 7 8 9 10 11 and so on and so forth. And then you're going to draw random numbers, or you're going to put their numbers in a fishbowl and then draw that one. So it is draw lots. So whoever picks number 4, then he will be the number 4 will be part of your study. Then if you're going to pick again, then you will pick number 20. Then number 20 individual will be part of your study until you satisfy your sample size, and that is 10. Okay. So in systematic sampling, okay, so if this is your whole individual, your whole population, then you only, as said, and then you're going to assign numbers again, 1 2 3 4 5 and so on and so forth. And then um you're going to pick individuals by 2. Okay, so you have to start by 2. Then you're going to pick um, another individual, um, um, what do you call this one? From the 1, 2, 3, 4, 5. Okay, so you're going to pick number 5, then skip again 2 person, then you're going to pick again this person until you satisfy your sample size. Okay, so that is systematic sampling. In stratified sampling, okay, so if this is your general population, for example, we have um, male and female here, okay, male and female. So you're going to go this one. You're going male and female of section A and section B. Okay, so you're going to pick, I sorry, section A. So you're going to pick 2 individuals here, and you're going to pick 2 individuals from the other section. Okay, so that is stratified sampling. So you have what do you call this one? You have subgroups. Okay, in cluster sampling, Okay. In cluster sampling, if this is your sample, then you have different subgroups. For example, section A, section B, section C, section D, and section E. Instead of getting sample from every section, then you just have to gather the whole section and be part of your study. So you're going to pick whole section B and you're going to pick whole section D to be part of your study. Okay, so next one is a non-probability sampling method. So we have four types, namely convenience sampling, wherein participants are selected based on availability and willingness to take part. Quota sampling, interviewers are given a quota of subjects of a specified type of attempt to recruit, and purposive sampling relies on the judgment of the researcher choosing who asked to participate. And lastly, we have snowball sampling, in which it is used when investigating hard to reach groups. Okay, so here is the representation or example. So snowball sampling, if this is you, the researcher, you're going to interview this person. Okay, you're going to interview this person. Then you're going to ask this person if they have something to refer to be part of your study. Okay, so they refer this person, and this person. Then you're going to interview them. While this person refer to you this person, and this person, then you're going to include them in your study. So that is snowball sampling. While quota sample is that you're going to you have a quota. For example, in a group of you are only given of 300 or 3%. The quota in every survey is 3%. Then you will only get 3% in your sample size. Of course, they should be willing to be part of your study. Okay, and judgment or what do you call this one? Judgment or purposive sampling. So judgment or purposive sampling is that um, you on have a criteria on which of the individuals will be part of your study. Okay, for example, you're going to interview obese individuals. So you have a criteria. What are the criteria of being obese? So what is the weight? Okay, and what is the BMI, body mass index? So you have to include this one in your criteria in order to fulfill your your or satisfy the criteria of who will be part of your study. Okay, that's why it's judgment. So you're being judgmental, that you have to make sure that this person will fit your criteria. Then we have your convenience sampling. In convenience sampling, by the name itself, convenience, so you will only include all those persons who are close to you, or you can or it they can be easily reached. Okay, that's why it is called convenience sampling, because they're just there. They are not you're they are not hard to reach. So that's why it's convenience sampling. Okay, take note of this, that why do you need to know all of this? Because statisticians should know what is the sample size if you're going to um, statisticians should know the sample size in order for you to know um, in order for you to infer and draw conclusions based on these and based on the sample. Then you're going to infer that one to your population. Okay, so you also needed this one in doing your thesis, whether you're going to do qualitative research or quantitative research. Now, what is the importance of sampling? So, sampling is necessity. Okay, so it is also practicality, cost effectiveness, and manageability. Okay, so if you're going to do your study and you're going to interview um, some specific groups, it is better for you to have a a sample rather than getting the whole population, because it will take time for you to get the whole population. um, it will take time and it will cost you a lot, because of course the money that you're going to spend. So it is very um, it is not that practical to do that one in your study. Okay, so it is better that you're going to draw only from the sample and then make inferences um, based on your sample. Okay, that mm. Now let's start your journey on your statistics, and you wouldn't know that this this one is also used in statistics, and I think that um, most of you knows how to do this one because this is only a basic math. So we have percentage. Okay, so percentage is defined as per 100. So it is also a proportion, and it is expressed in a uh, percent or this symbol. Okay, so how to do that one is you have to divide the total or whole number and multiply that one in 100 in order to get the percentage of a certain number. Okay, so let's have an example. So if 21 of 300 students found were female, okay, calculate the percentage. So let's have your formula. Okay, percentage. Divide that one by the total whole number, then multiply that one to 100. Okay, so 21 divided by 100 is 0.07 times 100, and that is 7. Okay, so therefore 7% of the population of the school were female students. And of course, let's have another example. So let's take this an example. So there are 450 students in class and 123 were male. So you have to find the percentage of the male students. Now, what are going to do that one, or how are going to solve it? First is to analyze the problem. So you have your total number. So you have 450 students as your population. Okay, so this will be your population. And then you have 123 male. Okay, so you have to get the percentage. So in order to solve that one, percentage is equal to 123 for male over 400, or divided by 450, the total number or the total population, multiplied by 100. Now, what is the answer? So 123 divided by 450. So this is um, 0.3 multiplied by 100. Therefore, your answer is 27.3%. Then you have to include percent at the end of your answer, or your final answer. So 27.3% were male students. So you have to be specific on your general answer. Okay, so another one. Let's have another example. So for example, we have um, this example now. But we have to modify your um, problem. Find the percentage of female students. Okay, so first you have to analyze. Of course, you have 450 students as your general population. Okay, so you have 123. This is your male. Okay, so you are looking for find X for female. Now, how are you going to solve that one? You have to write that one. So X female over 100. So since we are looking for female, the one that we're going to write here is that 450 minus 123, which is the number of male, of course divided by the total number of the population. Okay, in order for us to get the number of the female students here. So 450 minus 123 is equal to 327. Erase this one. 327 divided by 450. Okay, so that we're going to find the percentage only for female. So let's cross multiply the opposites. So x, do that one here. So x times 450 is equal to 450x is equal to 100 times 327 is equal to 32,700. Then we're going to divide both sides by 450 in order for the x to retain on this side. 450 by 450. So x, going to cancel 450 there. X is equal to where's my cursor? Okay. X is equal to 72.67% were female. This will be your answer. Okay. So I will be sending some exercises later. Okay, in order for you to practice um, how to calculate for the percentages in just simple word problems. Okay, so lastly, percentage is appropriate when it is important to know how many of the participants gave a particular answer. Okay, so that is the importance of getting the percentage in a certain study. So that ends our discussion. So prepare for an activity later, and make sure to submit that one on time. Okay, thank you so much. Thank you for listening.